Okay, so kinematic equations.
On the second one, does it say AD or AT? Yeah.
AD.
Is that AD?
After
Okay, so this is the first big gift of level 2 mechanics to you, the kinematic equations. And the good thing is in maths class they love to go through and derive how you get these things. So we're not gonna. We'll leave your maths teacher the pleasure of going through and deriving these equations for you. The cool thing is these are going to let us solve any motion problem that includes acceleration. So previously we were only able to solve motion problems with acceleration by graphing the speed time graph and then trying to interpret things from the speed time graph. Using these equations, these incorporate acceleration. So VF means final velocity, VI is initial velocity, A is still just acceleration, T is still just time, and D is still just distance. And you'll notice that there's 4 different versions of these equations. So we just have to find the right one to fit the situation that we're given by identifying what quantities we know and what we're trying to find out. And we'll find that we always know 3 things and we're trying to find the 4th one. And there's a few little tricks, like often acceleration is going to be gravity. So whenever it's a problem involving things going up or down, the acceleration is just going to be the 9.8, the negative 9.8. And often our problem will hide the VF or the VI in the wording by using things like at rest or stationary or stopped. And that will tell us that either our motion begins at rest or ends at rest. And so you often look for the A to be gravity and look for either the VF or the VI to be 0. The third one is particularly hard to rearrange unless VI is 0, because if you look at it you'll notice there's a T and a T squared, and so we can use that one but we'd have to make it into a quadratic equation unless VI is 0. So look for this one to be really useful when the initial velocity is 0, and that just cancels that term and we're left with D as half AT squared. They leave these 2 equations on your formula sheet. Don't use them. Like, hardly ever. Speed is distance over time only at constant speed. So only when acceleration is 0 can you use that equation. It's work of the devil leaving it on there. You can always use one of these equations and just put in A equals 0 and you will get that same equation. Look at this third one down here. If A is 0, we're left with D equals VIT, which is the same as what we would get if we rearrange that. So we don't need that equation at all. It is useful to know that we can use it when the speed is constant. The second one, acceleration equals change in speed over change in time. We could rewrite that as VF minus VI over change in t, and then we could see hopefully that this equation here we could also rewrite as acceleration is VF minus VI over change in t. So we can see that that equation there is like an oversimplification of this one. This doesn't have VF and VI, it just has change in V. This one's better because it lets you plug in the numbers that you've got. So use the kinematic equation, avoid the temptation of the devil.
Thank you.